All right, so our objective for today is to be able to write a piecewise equation. So yesterday we graphed them. Today we're going to look a little bit more at graphing, but we are also now going to look at writing the piecewise equations. So you're going to investigate writing the equation given the graph. So go ahead, I want to go backwards a little bit and look at the warm-up. So this is called function notation. 1 through 4 all deal with function f. So they're coming from the first function up here. And what you have to do is pay attention to the function value you're looking for. F of 2 only has one answer. F of 2 only has one answer. It comes from the point where 2 is true in the inequality. So is 2 less than or equal to 0? No. Is 2 greater than 0? Yes. So f of 2 would equal 2. So go ahead, take a minute and work on a couple of those, and we'll go over them. Okay. So f of -4, you plug -4 into x less than or equal to 0, and we get 3. F of 0, so you pick the one where it's equal to 0, which is also 3. And 1/2. 1/2 is greater than 0, so that is 2. G of 7. 7 is greater than or equal to 3. So you get 2 times 7, which is 14, minus 1, which is 13. 0 is less than 3, so you plug it into the top equation, and you get 5. -1 is also less than 3, so you plug it into the top equation, and you get 4. 3 is equal to 3, therefore it goes into the top, and we get 8. -4 for h, so -4 is less than or equal to -2. So -4 times 1/2 is -2. -2 minus 4 is -6. -2 goes to the equal, which is the top, so you get -1 minus 4, which is -5. -1 is greater, so you plug it into the bottom, so you get 3 minus 2 times -1. So 2 negatives make a positive, so we get 5. 6 is also greater than -2. So you get 2 times 6, which is 12. 3 minus 12 is -9. Okay, so just like yesterday, we're going to focus on graphing and writing piecewise equations. So we have a piecewise that is broken down into 3 parts. So that means there are 3 breaking points. So I need values of x less than 0. I need values of x between 0 and 2. And I need values of x greater than 2. For values of x less than 0, we have a closed circle. From 0 to 2, it goes open to closed. And then greater than 2 is open. So again, because it goes closed, open, this should pass the vertical line test, making it a function. So for x values less than 0, it goes into the equation x plus 3. So that means at 0, we're at 3. At -1, you would be at 2. And at -2, it's at 1. So that gives a linear equation that continues to -infinity in both directions. Here in the middle, we have a constant. The constant is at 3. So what we notice is that the point 0, 3 overlaps with the point that is already there. So when an open and closed overlap, it just stays closed. So even though this middle equation is open, since it's closed underneath, it represents a closed point. So that's the horizontal line from 0 to 2. And at 2, we plug into the new equation. 2 times 2 is 4. 4 minus 1 is 3. 2 times 3 is 6. 6 minus 1 is 5. 4 times 2 is 8. Minus 1 is 7. So we have the open circle at the point 2, 3. Then we have 3, 5. And 4, 7. So bless you once again. An open and closed circle overlap. So this is actually what we call a continuous function. The domain is all reals, and the range is all reals, because the graph continues infinitely in both directions. And for every y value, there is an x value, and for every x value, there is a y value. Now, this is not one-to-one because of the horizontal line there in the middle. Oops. Okay, graph the piecewise. So once again, my breaking point is at -2. So if I am to create a table, I know that I need to repeat -2. So values less than -2 are -3 and -4. Values greater than -2 are -1 and 0. And again, we have to decide which plugs into which. So values of x less than -2 go to the equation x minus 4. So -4 is -8. -3 and -4 is -7, and -6. We have a closed circle at that point, -2, -6. Okay, -2 plus 3 is 1. -1 plus 3 is 2. And 0 plus 3 is 3. So at -2, 1, it is an open circle. So this is a function because at the point of overlap, one is closed, one is open. It is not continuous because we jump from the point down here to the point up there. So this is not continuous. Therefore, my domain is all reals, but my range is not. So my range, it goes from -infinity to the point -6, including -6. So if you're using interval notation, it would get a bracket. And then it's 1 to infinity, but doesn't include 1, so it gets a parenthesis. Now you could use the y terms as well. So it would be y less than or equal to -6. And then you would have to say, and y greater than 1. So again, either notation is fine. Just two different ways of saying the same thing. So in the past two examples, we were given the piecewise and we drew in the graph. Now we're given the graph and we need to write the piecewise. So you need to go over to the graph, and the first thing I always do is look at my starting points. So this point right here is -1, -1. So that means this graph right here is represented by x values less than but not equal to -1. The graph over here starts at 1, 2, which means it represents x values greater than 1. And since it's a closed circle, also equal to 1. Once you have your inequality, you can kind of think of this line as continuing in its opposite direction. So the slope is up 1 over 2. So we can figure out the slope. Then you need to take that idea in reverse and figure out your y-intercept. So it goes down 1 and left 2. So its y-intercept is down 1/2. So if this is the point 1, 2, its y-intercept is at 1.5. You could also use point slope form. So you could use the point 1, 2 And you could have said y minus 2 equals 1/2 x minus 1. And you could have distributed and combined like terms. And also saw that you got to 3/2. So the blue part of the piecewise is represented by 1/2 x plus 3/2 for x values greater than or equal to 1. The red equation has a slope of up 1 over 1. So it has an x value of 1x. And again, if we continued that pattern, my next point would go through the origin. So it's kind of like 1x plus 0, or simply 1x. So the equation is y equals x for x values less than -1. Okay, this equation has 3 parts. So we need 3 breaking points. So this is at -2. And this breaking point is at 4. So that means this is x values less than, but not equal to -2. The middle segment goes from -2 to 4. And equals on both ends. And the last segment is x values greater than, but not equal to 4. So then I always think it's easiest to start with the intervals and then figure out the slopes of the lines. So the beginning and the end, so this graph right here, that's a horizontal line. A horizontal line has a slope of 0. Therefore, it is the y value. So that is down 1, 2, 3 units. So for x values less than -2, f of x is -3. And then at the bottom, we have x greater than 4. Well, over here, x values greater than 4. This line is also a horizontal line. So the slope here is 0. And it's up 1, 2, 3, 4, 5 units. So the equation of the line for x values greater than 4 is 5. For the middle line, the y-intercept is 0, 0. And the slope is up 1, right 1. So the equation of the middle line is just x. Okay, real quick, let's do one more part. Let's talk about, is this a function? Yes. Is this continuous? No, because it jumps from one point to the other. So it is a function. It is not continuous. It is not one-to-one. It is onto. And then our domain is all reals. However, once again, my range is not. My range is y equals -3, y equals 5, and then y values from -2 to 4. Okay, so your homework is that very next page in that packet. You're doing a combination of the two things we just did again today. You're going to be writing the equations for the graphs. And then I think you're also going to be graphing a couple. Okay? So again, you're doing that next page, front and back. The page we did last night and that page today need to be uploaded by noon tomorrow. Not the end of the day, by noon tomorrow, so that I can release the answer key so you can bring in questions on Thursday. So you have till noon tomorrow.